What have the Hulk and Spider-Man got in common? They both gained their superpowers because of radiation. Well, in films and comics at least. In real life, radiation has never given anyone superpowers, but when used carefully, radiation does have many uses, which we're going to look at in this video. Remember, the nucleus is found at the center of all atoms. Some nuclei are unstable and may emit alpha particles, beta particles, or neutrons, and electromagnetic radiation as gamma rays. Watch this video to understand exactly what these types of radiations are. Gamma radiation can be used in radiotherapy for the treatment of cancer. Gamma radiation is directed at the area of the body affected by cancer. At high doses, radiation kills cancer cells or slows down their growth by damaging their DNA. These dead cancer cells are broken down and removed by the body. Radiotherapy doesn't work straight away. The cancer cells can take up to a few months to die and be removed by the body. Radiotherapy can also be used to destroy other tissues in the body that are not useful. For example, radiotherapy is often used in the treatment of overactive thyroid glands. If the thyroid gland produces too much thyroxine, it can result in heart palpitations, anxiety, tiredness, and mood swings, amongst other symptoms. Radiotherapy can be used to destroy some cells of the thyroid gland and thereby reduce the amount of thyroxine that is produced. Beta and gamma radiation can also be used as tracers. Tracers in the body can provide a useful alternative to surgery. A small amount of radioactive material is introduced to the body, and a radiographer follows the passage of this material through the body using specialized equipment. Beta and gamma sources are used because they pass out of the body and so can be detected. Remember, alpha radiation can't travel through anything thicker than a sheet of paper. Barium meals or barium enemas are common examples of radiation used in this way. Smoke detectors emit a constant stream of alpha particles. A sensor continually detects these alpha particles, causing a small current. If smoke particles come between the source and the detector, the current is decreased and an alarm goes off. Gamma radiation is used to sterilize hospital equipment and is also used to kill bacteria, mold, and insects from food before the food is packaged. This increases the shelf life of the food. The food is safe to eat and doesn't become radioactive itself, as it's irradiation rather than consumption. Watch this video to learn about the different types of radiation and the hazards involved. These are just a few uses for radiation. There are many, many more. While radiation can be extremely useful, unfortunately, it won't make us superhuman.
In today's video, we're going to look at the terms irradiation and contamination, and we'll see what it is that makes radiation harmful. Irradiation is the process by which an object is exposed to radiation, and that could be radiation of any type. So ionizing radiation, like alpha particles, beta particles, gamma rays, or X-rays, but also non-ionizing radiation, like ultraviolet or microwave radiation. So if any radiation of any type was to reach your body, we'd say that you had been irradiated. Contamination, on the other hand, is when radioactive particles get onto other objects. So if you had some radioactive uranium on your arm, then we'd say that you're contaminated. Now, contamination itself isn't actually a problem. The real issue is that the radioactive material that you're contaminated with is likely to decay and irradiate you. And it's this increased risk of irradiation which is the issue. The next thing we need to look at is what determines how harmful radiation is. This depends on a range of different things, but the main ones are what type of radiation it is, where you're exposed to it, and the amount of radiation that you receive. We saw earlier that there are loads of different types of radiation, and that they can be split between ionizing and non-ionizing. Generally, it's the ionizing ones which are the most dangerous, because they can enter living cells and interact with the molecules inside. In particular, the radiation can ionize our DNA, which can cause mutations. And in rare cases, this can lead to the cells dividing uncontrollably and developing cancer. One thing we should add is that ultraviolet radiation can also lead to cancer, even though it's not always considered to be ionizing. If we arrange them all in one long list, from the most harmful to the least harmful, then it would look like this, with alpha being the most harmful, and radio waves not being harmful at all. However, the order of this list changes depending on the location of the source. If the source is outside the body, then alpha stops being the most harmful, because it gets stopped by a short distance of air, and can't penetrate the skin. Beta and gamma radiation, on the other hand, can penetrate the skin, and so for external sources, these two are by far the most dangerous. If the source is on the body though, like in the case of contamination, or if it's inside the body, for example if you ate something that had been contaminated, then alpha radiation would be the most dangerous, because it would be able to make it into your cells. The last factor we mentioned was the amount of radiation that you're exposed to, which we can call the dosage. This will depend on three things: how far away from the source you are, how long you're exposed to it for, and most importantly, how radioactive that substance is. In order to minimize irradiation and avoid contamination, we need to take precautions whenever we're around radioactive sources. This includes wearing protective gear, like gloves and overalls, but also handling the radioactive item with tools like tongs, rather than using our hands directly, and keeping the item in a lead-lined box whenever possible. One last thing we should mention is that being irradiated can't cause you to mutate into a mutant in any way, and can't make you radioactive. So if you've been exposed to lots of radiation, you can't then emit that radiation to others. It's only if you're carrying a radioactive source, and so being contaminated, that you could then harm others.
Radiation can be dangerous to living organisms because radiation ionizes, and this means that it can knock out electrons or put electrons onto atoms and molecules, and making them charged particles. And these charged particles can go on to be involved in chemical reactions in the living organism that perhaps they shouldn't be. This can damage cells, kill cells, and damage DNA, perhaps leading to cancer. So it's important that we know how we should handle, use, and store radioactive materials so that we ensure the maximum safety. So here are 4 points for handling, using, and storing radioactive material. Well, firstly, we can wear protective clothing. Protective clothing. It may be as simple as wearing gloves, or if you are a radiographer in a hospital dealing with X-rays, you may be wearing a lead type of vest to help minimize your exposure to X-rays, which are also a type of radiation. Number 2, keep your distance between you and the source. Keep distance between yourself and the radioactive source. Now this is because alpha particles in air have only got a range of 2 or 3 centimeters, and beta particles have got a range of 1 meter or so. So if you can keep the source quite far away from your vital organs, then that's going to reduce your radiation exposure. And a good way of doing that is to use tongs, which will extend the distance between your body and the radioactive source. Number 3, minimize your exposure time. Minimize your exposure time, the length of time that you are working with the radioactive material. The longer you work with a radioactive material, the longer your exposure and the more radiation you will have absorbed into your body, which can cause more damage. And finally, number 4, how should it be stored? We can store radioactive materials in lead-lined containers correctly labeled with a hazard symbol. For example, something like the symbol shown here, which is a radiation hazard symbol. Lead will absorb alpha, beta, and it will reduce the intensity of gamma radiation. So storing materials in a lead-lined container is a good idea to reduce the radiation that might come out of that and expose the surroundings. So there we are, 4 ways to keep safe when working with radioactive materials and to reduce your exposure.